Hello students, welcome to Learner's Planet, our session of chemical reactions and equations. In our last session, we discussed about the heat changes in the chemical equation. Okay, we discussed about exothermic and endothermic reactions. Now let's discuss few more types of reactions. Now students, there are 5 types of chemical reactions: combination reaction, decomposition reaction, displacement or substitution reaction, double displacement reaction, oxidation reduction reactions. So let's first start with the combination reactions. Combination, as the word indicates, combine. That is, the two substances are combining and a new product is formed. Addition, it's the same thing. The two substances are being added and a new substance is formed. Synthesis reaction. Why it is called as synthesis reaction? Because again a new substance is synthesized or formed. Combination or addition or synthesis is a chemical change in which atoms or molecules of two or more substance combine to form molecule of new substance with different chemical property. That is, the molecules are added and they form a new substance with a different property. For example, hydrogen burns in oxygen to form water. Now students, here hydrogen is a gas with different properties of it. Oxygen is again a gas with its own properties. But when these are combining, when you are heating hydrogen in air or in the presence of oxygen, what is formed here students? It is water. Water is a liquid. There is change in state. There is change in chemical property of hydrogen and oxygen. Now what you are getting is altogether a new substance, that is water. So this is a combination reaction. We have a second type of reaction, that is decomposition reaction. Now students, before discussing decomposition reaction, I would like to give you one more example of combination reaction. And that is, we discussed there the formation of ammonia or the formation of carbon dioxide, or I can write here an equation for the formation of ammonia. Now here students, what happens that N2 gas, that is nitrogen gas, combines with hydrogen gas and it forms what? Ammonia molecules, 2NH3, and it is again a gas. So it is N2 plus, for balancing what I'll do is, I'll write 3 here. Thrice of H2 gives 2 ammonia. Now here also, what is happening students? Nitrogen gas is combining with hydrogen gas, giving what? Ammonia. Likewise, carbon combines with oxygen, giving carbon dioxide. Likewise, sulfur combines with oxygen, that is S plus O2 gives SO2. Tell me one more example of combination reaction. H2 plus Cl2 gives twice of HCl. Do you remember? That is H2 plus Cl2 gives 2HCl. So students, wherever you are finding two substances combining and giving a new substance, it is what type of reaction? It is a combination reaction. Now students, our next type of reaction is decomposition reaction. Now what do you mean by this? A chemical reaction in which molecules of a compound breaks into two or more simpler compounds is known as decomposition reaction. Decomposition, what does this mean? Decomposition is simple, breakdown. Now students, for breaking up a compound, what you require is you require energy, or the chemical reaction requires energy. Now how can that energy be supplied? Energy for decomposition can be supplied by, there are two pies here. So energy for a decomposition reaction can be supplied by applying heat, light or electricity. So you know students that all these are the forms of energy. So you can supply energy in any form. Now let's discuss few examples of decomposition reaction. What is it? If blue crystals of copper nitrate are heated, they undergo decomposition to give black colored copper oxide, reddish brown fumes of nitrogen dioxide and colorless gas oxygen. Now students, copper nitrate. What is the symbol of copper? Cu. What is the formula of nitrate? NO3. What is the valency of copper? 2. NO3 has a charge minus. So what will be the formula of copper nitrate become? It would be CuNO3. Okay, that is valency of copper. I'll write here, it is valency of copper is 2. Charge on nitrate is NO3 minus. So what will be the formula of copper nitrate? It would be CuNO3 twice. Now thermal decomposition. What does this word thermal means? Thermal means heat, therma, increasing temperature. Now when I am increasing temperature, what I am getting is that this particular molecule, which particular molecule? Copper nitrate. It is dissociated into copper oxide, nitrogen dioxide and oxygen. Now I told you that you have to write colors in the chemical equation. Now your copper nitrate, what color is it? Blue. Black color of copper oxide and reddish brown color of nitrogen dioxide and oxygen are formed. So students, this is an example of thermal decomposition. Now always remember students, whenever a nitrate decomposes, what you get is a particular oxide, nitrogen dioxide and oxygen. So now here your question can't be direct. Your question can be copper nitrate dissociates, or on heating copper nitrate gives reddish brown fumes off, and you have to fill in the blanks. I'll write my question here. So as you are growing up, your questions, the standard of the questions will increase. It can be on heating copper nitrate reddish brown fumes of dash are obtained. So always remember children, whenever there is a nitrate being heated, what will you obtain is NO2. Say if I am heating ammonium nitrate, or if I am heating lead nitrate. Lead nitrate when heated will give lead oxide, nitrogen dioxide and oxygen. So this is one of the example of decomposition reaction. Clear? I'll take another example here. That is when mercuric oxide, what is the color of mercuric oxide? It's red. Is heated, we are getting mercury, that is silvery and it is liquid, and oxygen gas. Now what sort of question can be asked out of it? It is a red colored substance on heating is giving mercury in liquid state and oxygen gas. So what is your red color substance? It is HgO, mercury. Mercury, the symbol for mercury is Hg. And the valency of mercury is, what is the valency of mercury, students? The valency of mercury is 2. or 1. Every time I am telling you valencies so that you can write down the chemical formulas of it. So this is your decomposition reaction. Now I will discuss here a few more examples of decomposition reaction. That is, till now what we were doing, children, we were like supplying heat energy to break up a molecule of either mercuric oxide or copper nitrate. So that was called as what? That was thermal decomposition. Now here I told you that for a decomposition reaction, energy can be supplied by electricity also. In this example, that is decomposition of molten lead bromide on passage of electricity. Molten lead bromide. Now there are two things, students. It can be molten or aqueous. Aqueous is, that is lead bromide is dissolved in water. Molten means it is a molten form of it. There is no water in it. Now students, if I have taken molten lead bromide and I am passing electricity through it, so it will break down into lead solid and bromine liquid. Now in this case, as it is done by passing electric current, so what type of decomposition it would be? It would be electrolytic decomposition. Now we've got another example here, that is molten sodium chloride on passage of electricity. So molten sodium chloride, again the state of it would be liquid. It will dissociate into sodium solid and chloride gas. So when you find any molecule being dissociated into two, it is what type of a reaction? It is a decomposition reaction. I hope now you can distinguish between a combination reaction and a decomposition reaction. Now we have another type of reaction, students, that is displacement or substitution reaction. Now a substitution or displacement reaction is a chemical change in which atoms of one element replaces the atoms of another element from the molecules of a compound. This definition will be clear to you when we will discuss examples. Now there is another point written here, that is more reactive element displaces a less reactive element from its compound. Now it is a completely new term for you. Now what do you mean by this reactivity? There are certain elements like sodium, potassium, calcium. They are highly reactive. Highly reactive means as soon as they are coming in contact with another chemical compound, they will react. And this reaction of sodium with water is even explosive. In your labs, if you will put sodium tallate on the sink having water, it will blow. Right? It will ignite. So never do that. So these are most reactive. The less reactive elements like iron, copper, lead, these are less reactive than these sodium, calcium, potassium. Got my point? Or magnesium. The least reactive elements are gold, silver, zinc. These are the least reactive. Now for the sake for convenience, what is done is that these elements are arranged in a reactivity series. So the element which is less reactive will displace or replace the element which is more reactive. Now let's discuss few examples of it so that displacement reaction is very clear to you. There is an example, that is when an iron knife is dipped in aqueous solution of copper sulfate. The iron from the knife, being more reactive than copper, displaces it from copper sulfate. Now students, iron, what is the name of it? Ferrum. What is the symbol of iron? Fe. Copper, what is the symbol of copper? Its name is cuprum. C-U-P-P-R-U-M. What is the symbol? Cu. Sulfate. Sulfate is, students, SO4 2 minus. So I can write it here. Sulfate. It is sulfate. Sulfate is what? It is an ion, that is SO4 in brackets and 2 minus. So what will be the formula of copper sulfate? CuSO4, because valency of copper is 2. Here I'll write the valency also. Now we've got copper sulfate. Now if I'll dip iron in copper sulfate solution, what I'll get is iron sulfate and copper. What does this mean? That iron is more reactive than copper and it has formed bond with sulfate, forming iron sulfate and copper. Copper gets precipitated. Now here also, students, you can find that the color has been written to make the equation more informative. The states of substances has been written. Iron solid, copper sulfate aqueous, iron sulfate aqueous, and again copper solid. So in a way this equation is informative. And what do you mean by this down arrow? Down arrow means things have been precipitated. So students, whenever you are writing an equation, try to make it more informative, so that it is telling you about the states, about exothermic or endothermic, or about the precipitate formation, or about the color change. The copper so separated gets collected on the surface of iron knife, giving it a reddish brown color. That is, your iron knife turns reddish brown. Now in this case, students, what type of question you can get from this equation? I can ask you that there is a deposition of red substance on iron knife when dipped in CuSO4. What is that red substance? Got it? Note down the question. There is a deposition of a reddish brown substance on an iron knife or an iron block when kept in copper sulfate solution. Name the substance deposited. So what it will be, students? It will be copper. So this is an example of displacement reaction. See here what has been done. Iron has replaced copper and formed iron sulfate and copper deposited. Let's take another example. That is, when a strip of zinc is placed in copper sulfate solution, zinc being more reactive displaces copper from copper sulfate solution, due to which copper is precipitated out. That is, copper sulfate aqueous to this zinc solid is being placed, then zinc is displacing what? Zinc is displacing copper and forming what? Zinc sulfate. Again your copper is precipitated. So to make it more informative, what I can do is, I can just put a arrow pointing downwards like this. It means what has happened is your copper has been precipitated out. Precipitated, and where it will get deposited, students? Your copper solid has been precipitated out, and just tell me where it will be deposited. It will be deposited down. Solid and precipitated out. So students, this is an example of displacement reaction. Now in both the equations we have seen that copper is less reactive than zinc and iron. Had it been, students, if I will dip copper in silver sulfate solution, what will happen? Here copper is more reactive than silver. So what will be formed is copper sulfate and silver would be precipitated. So depending on the reactivity, the compounds are formed. Now here what you have to do is you have to just identify the type of chemical reaction, whether it is combination or it is decomposition or it is displacement. That's it, students. Okay. Now let's take another example, that is when a colorless solution of potassium iodide is passed through a colorless solution of chloroform. The chloroform layer becomes purple. Chlorine, being more reactive than iodine, forms potassium iodide. Now just tell me one thing, students, from where this chlorine has come? From where are you getting this chlorine? Chlorine is coming from where? From where this chlorine is coming? Chlorine is coming from chloroform. Now what is the formula of chloroform? Here we have got a few compounds, that is potassium iodide. What is the symbol of potassium? Potassium symbol is K. What is the symbol of iodine? I. What is the valency of potassium? Valency of potassium is 1. Valency of iodine is 1. So what will be the formula of potassium iodide? It will be Ki. Then colorless solution of chloroform. What is the formula of chloroform, students? It is chloroform is CHCl3. Now this chlorine is coming from chloroform. Now chlorine being more reactive, what it does is it replaces iodine from potassium iodide. Getting my point? I'll show you here. Chlorine is coming from chloroform. This chlorine is replacing what? Iodine. And forming what? Potassium chloride. And iodine is precipitated. So, chlorine being more reactive than iodine forms potassium chloride, not potassium iodide. So, it is potassium chloride. So, this is also the example of displacement reaction. Now let's discuss another type of reaction, that is double displacement reaction. Now when a single displacement, what do you mean by single displacement? That one substance has replaced the another. Like in our previous slide, we saw what? There is only chlorine replacing iodine. Now in double displacement, what is the difference between displacement and double displacement? Those reactions in which compounds react by an exchange of ions to form new compounds are known as double displacement reaction. This reaction occurs in solution as ions are formed in solutions only. Now what does this term mean? Those reactions in which compounds react by exchange of ions. Say, I have got this compound A plus B minus, and I have another compound C plus D minus. Now there is exchange. D is being exchanged for B and B is being exchanged for D. Now I have got two different types of compounds, AD and CB. Is my point clear? Now students, here what is happening? Here ions are formed. Now when ions are formed, where these ions will be formed? Will they form in solid state? No, they are not going to form in solid state. They are formed in solution. So this type of reaction occurs in solutions. Let's take this example. Sodium chloride aqueous plus silver nitrate aqueous gives what? Sodium nitrate aqueous plus silver chloride solid. It means nitrate has replaced chlorine. Chlorine has replaced nitrate. So what is going on here? This is double displacement. That is nitrate replacing chlorine, one displacement. Chlorine replacing nitrate, another displacement. So there are two displacements here. Now this is a double displacement reaction. So in this case, what is happening here is that the two substances are displacing each other. So this is an example of double displacement reaction. Now in this session, students, we have discussed about combination reaction, decomposition reaction, displacement reaction and double displacement reaction. So these are the four types of reactions which are very, very important. Now you must practice reactions. So now you should see reaction and try to identify it, what type of reaction it is. In our next session, we'll discuss few more types of reactions like neutralization reaction, oxidation reduction reaction. So till then, students, just try to practice as many chemical reactions you can and balance as many equations you can. Okay?